Hello everyone, this is my third video on practice bits of current. In this we are discussing about electric shock, electric power, overloading, Kirchhoff laws, Faraday's laws, electroplating, Faraday's laws of electrolysis. So first let us see electric shock. So just I am giving how we will get shocks, a small explanation. Actually the resistance of human body is 100 ohm to 5 lakh ohm. 5 lakhs ohm, 100 ohms to, means this much resistance the human body is having. When small currents passes through human body, it does not affect any functioning of organs inside the body. For example, from 24 volt battery, 24 voltage battery, let us think that a current has passed into our body. Let the resistance of our body be 1 lakh. Resistance of our body will be 1 lakh. Then how much current passes? I equal to V by R from Ohm's law. No. 24 by 1 lakh, that is 0.00024 ampere current is flowing. So this is very small amount of current, so it never affects the functioning of our body or tissues or organs in our body. Now let us think that from 240 volt battery, if resistance of our body is 1 lakh, how much current flows? 240 by 1 lakh, that is 0.0024 amperes. Means current passing through our body has increased. So this disturbs the functioning of organs. Now this disturbance only we call it as electric shock. This disturbance in functioning of our organs by passage of current into the human body, we call it as electric shock. If current flows for longer time, it damages the tissues of the body, resistance decreases. If current is nearly 0.07 amp, that current will affect the functioning of heart. Either person becomes fatal, which causes to death. Right? Now here, if in amperes I am taking, if 0.001 current flows, we will feel that. If 0.005 ampere current flows, it causes some pain. If 0.015 current flows, it causes loss of muscle control. If 0.07 ampere current flows, if it passes through the heart, then it causes serious disruption. Right? Next you have see that birds stay on high transmission lines, high voltage wires, but also then does not die. Why? Why means, just I am saying a small explanation related to it. Now actually there will be two transmission lines on electric poles. Potential difference between these two transmission lines will be 240 volt. If we connect anything across these only, then a potential difference of 240 volts passes from one wire to other wire. If we don't connect anything, then this passage of voltage will not be there. And bird, it stands on one wire only. Okay, it stands on one wire only, so it does not undergo any electric shock and does not die. Right? Now next, let us move for electric power. Electric power means voltage into current. By applying Ohm's law IR, we can write it as other formula I square R, or just add and multiply R. IR into IR, that is V into V, V square by R. This is also another formula for electric power. 1 kilowatt equal to 1000 watt, that is equal to 1000 joule per second. 1 kilowatt hour equal to 3.6 into 10 to the power of 6 joules. Now next let us move to overloading. Now overloading means, in a simple way I will say, in our home TV, fridge, bulb, fan are there. Right? Generally to our homes 240 volts will be transferred. Okay? So electricity enters our home through two wires, we call it as lines, and 240 voltage will be supplied. For 240 voltage, maximum current limit is 5 to 20 amperes. Okay. If now here you see, here TV, fridge, bulb, fan, maximum current is 20 amperes. I said no. TV takes 240 volt, we are sending. TV takes 6 amp, fridge 8 amp, bulb 2 amp, fan 4 amp, means 20 amp here it is taken by these electric appliances. Now extra we added heater. Our maximum limit is 20 amp. Extra we added heater means more than 20 amp. This has to draw the current. When it draws more than 20 amp of current, then these appliances, this circuit becomes overheats and causes fire. That we call it as overloading. Then how to prevent this overloading? How to prevent means by connecting a fuse. If any more current flows, then these fuse will melt and break. So our appliances will be safe. So we will take a very thin wire of low melting point as fuse. If any overcurrent flows through it, then this will break and our appliances will be safe. Now next, let us move for Kirchhoff laws. So for Kirchhoff laws, in my videos, I did a video on Kirchhoff current law and Kirchhoff junction law, that is junction law, voltage law separately. So for more details you can check that videos also. So Kirchhoff current law. Now this is junction. Some currents are passing towards the junction, some are away from the junction. Sum of currents passing towards the junction will be equal to the sum of currents passing away from the junction. This we call it as Kirchhoff current law. Next, Kirchhoff voltage law. So, or we also call it as junction law or loop law. Right? It says that algebraic sum of increase or decrease in potential difference across various components of circuit in closed loop is 0. Or V equal to IR? No, we can also write summation IR equal to 0. Now sign conventions. Okay. So sign conventions. Here first EMF of battery. Here in circuit, this is EMF of battery. Okay. EMF of battery, it is taken negative when we move from positive to negative terminal. It is taken as positive when we move from negative to positive terminal here. So how means EMF of battery? Now let us think that we are moving from positive to negative terminal. Okay. When we move from positive to negative terminal, we take EMF of battery with negative sign. If we move from negative to positive terminal, we take EMF with positive sign plus V. Similarly, potential drop across resistor. If we move in current direction and our moving direction are same, then it is taken as negative minus IR. If we move in opposite direction, our movement is opposite to the flow of current direction, we take it as positive plus IR. For your more understanding these 4 points, just I took a circuit in such a way. Let us think that our direction is A to B, B to C, C to D to E and E to A. So first here is V1. See, this is our movement. C to E means positive to negative. Positive to negative, what I said, when we move from positive to negative, we take it with negative sign. right? Minus V1 in such a way, positive to negative. Similarly, V2 positive to negative, minus V2. Now next, along resistors potential, only two batteries are connected, we wrote the EMFs of battery. Next, resistors are there, R1, R2, R3. There will be a voltage drop between these resistors. We have to write that also, IR. First, about R1, movement is in this direction and current flow is also in same direction. If same direction, what we said? Negative. So minus I1 R1. Here also current direction, movement direction same, minus I2 R2. Here also current direction, movement direction same, I3 R3. And the net potential will be equal to 0. Now let us move for our last part in this current, part 3, Faraday's laws of electrolysis. So electrolysis means the process of decomposition of solution. The process of decomposition of solution into constituents when electric current passes through it. So if we take any chemical solution and pass current through it, that chemical solution such as CuSO4V2, we passed current through it, it decomposed into Cu2 plus and SO4 2 minus ions. That process only we call electrolysis. And the vessel in which electrolysis process takes place we call voltmeter or electrolytic cell. Right? Now next, Faraday's first law of electrolysis states that mass of ions is directly proportional to the product of current passing through them and the time duration. Next, mass of ions liberated at electrode when 1 coulomb of electricity is passed through electrolyte we call electrochemical equivalent, ECE. The mass of ions liberated at electrode when 1 coulomb of electricity is passed through electrolyte we call electrochemical equivalence. Unit of ECE we denote with Z, gram per coulomb. Now chemical equivalent means ratio of atomic weight to the valency. Right? Now Faraday's second law says that the ratio of masses of ions liberated at electrodes is directly proportional to the ratio of their chemical equivalents. M1 is to M2 is to M3 equal to Z1 is to Z2 is to Z3. Now next, let us move for electroplating. Coating a thin film of metals on base metal. If we take any metal and if we coat thin films of metals, we call it as electroplating. So why this electroplating is there? It is the method of obtaining exact copy of engraved block containing letters or figures by electrolysis process. We want the exact copy of letters or figures from the block. So by using electrolysis process through electroplating method, by electrolysis process only we will get the exact copy of letters or figures on engraved block. Now next, copper, tin, lead, gold, zinc, chromium, nickel, so on are extracted by electrolysis method only. Electrotyping we use in printing industries. In electrolysis process, negative ions goes to anode of voltmeter. In refining copper metal by electrolysis, pure copper is used as cathode. In electroplating, metal to be coated is used as cathode. Powder used to be coated on surface of wax, mold to make it conductor is graphite or lead. Right? The least chemical equivalent value, hydrogen is having least chemical equivalent value. Thank you for watching my video. If you like my video, share and subscribe it. Okay. So for more topics such as magnetism, light, okay, sound, etc., you can check my playlist. You will get competitive physics. Even the topics under MSc entrance test physics also are very useful for JL exams, right? So once, even the arithmetic also, if you go to my playlist, you will see arithmetic. So maximum topics on arithmetic such as coding, decoding, right, logical Venn diagrams, seating arrangement, number puzzles, etc. Many I did videos and posted. Share it, like it, subscribe it. Thank you.